Well, we're going to look at a couple of exponential functions that have a lot of applications in many different areas. And those are exponential growth and exponential decay functions. And we're going to take a look here at a word problem in a moment, and then we're going to cover, I'll show you what the exponential growth function, or what a exponential growth function may look at. And then we're going to write that exponential growth function from the information that we receive in the word problem, and then we're going to make a prediction based upon that information. So we're going to build a model for exponential growth. Let's see here. We got a college tuition has risen 5% each year since 2000. If the tuition was in 2000 was $10,850, write an equation for the amount of tuition T years after 2000. And then we're asked to predict the cost of the tuition for this college in 2015. Well, let me show you the model for an exponential growth function, and then we'll fill in what we know. So if we had y equals a, and where a, let's say, is an initial amount. So a equals an initial amount. In our case here, this initial amount would be the tuition, $10,850 in the year 2000. So we have a times 1 plus r. Now r is equal to our rate, and that can be a rate of growth or decline, but in this case we see that we've got a 5% rate of increase, so we can say a rate of growth. Let's say r is rate of growth in decimals, not in percentage, and then t are the number of years that we're looking to determine. So let's see, if we got y equals a times 1 plus r raised to the power of t, where t is our exponent, therefore our exponential growth. Well, let's take some information here and let's plug it in. So we have y equals, well, 10,850, that's our initial amount, plus, times 1 plus, that's our 5%, 0.05, that's our 5% in decimal, and then raised to a certain number of years. So here is our initial growth function, 10,850 times 1 plus 0.05, our rate, raised to the power of t, the number of years in the, well, since 2000. Okay, well, we've done this first part. We've written the equation. There it is. We have written that equation. All right, now, so all we did was just take information that we were given and plug it into this exponential growth model equation. Well, let's see. Well, now we want to predict the cost of the tuition for this college in 2015. Well, the difference between 2015 and 2000 is 15. And so our t is going to equal 15. We've already determined that our r equals 0.05 and our a equals 10,850. Initial amount, the rate of growth, the amount of time, in this case it's time in years. So we've got y equals 10,850 times 1.05, where we added this together, raised to the 15th power. Now it's the 1.05 we're going to raise to the 15th power, and then we're going to multiply that times 10,850. Remember your order of operations. Parentheses, exponents, multiplication and division, addition, subtraction. So we're going to take care of our exponents first, and then we're going to multiply. And what we're doing is we're making a prediction based on this initial amount of 10,850. with a 5% annual increase in tuition, what is it going to be 15 years after the year 2000? Well, based on our prediction, the tuition would cost $22,556.37. In other words, it's going to more than double. That's ridiculous. Exponential growth functions.